Let's explore the intriguing birthday paradox. Have you ever wondered why it seems surprisingly easy to find two people in a group who share the same birthday? This is all about understanding why just 23 people in a room make shared birthdays likely. Before we dive in, consider this question. How many people do you think are needed for a 50% chance of shared birthdays? When faced with the birthday paradox, many people guess that you'd need a large group, perhaps around 183 people. The reasoning behind this guess is that since there are 365 days in a year, it seems logical that we would need about half that number, roughly around 183, for a 50% chance of a shared birthday. But hold on to your hats because the actual answer is quite astonishing. Prepare to be amazed. It turns out that you only need 23 people in a room to have a 50.7% chance of two of them sharing a birthday. Yes, you heard it right, just 23 people. This is far fewer than most people intuitively expect, and that is why it is called a paradox. But what makes this possible? Our intuition often leads us astray when it comes to the birthday paradox because of how we frame the problem. Our thinking goes like this: we tend to focus on the chances of one person matching their birthday with a specific other person. However, in reality, the key is that any person can match with any other person in the group. Instead of thinking about one-to-one matching, we should think about all the possible pairs that can be formed in a group. The key to understanding the birthday paradox lies in the power of pairs. With just 10 people, there are 45 possible pairs. This is calculated as 10 times 9 divided by 2, which equals 45. Now let's consider 23 people. In this case, there are 253 possible pairs. This is calculated as 23 times 22, divided by 2, which equals 253. As you can see, the number of possible pairs grows much faster than the number of people in the group. These increasing pairs increase the probability of a match. To solve the birthday paradox, we can use a mathematical approach. The strategy is to calculate the probability of the opposite scenario. That is, no shared birthdays instead of calculating the probability of shared birthdays directly. The formula for the probability of no match is as follows: P no match equals 365 divided by 365, multiplied by 364 divided by 365, multiplied by 363 divided by 365, and so on. Once we have the probability of no match, we can find the probability of at least one match using the formula, P at least one match equals 1 minus P no match. Let's see how we can calculate this using Python code. We start by initializing the variable prob to 1.0. Then we use a for loop that iterates from I equals 0 to 22. In each iteration, we update prob by multiplying it with the fraction 365 minus I, divided by 365. Finally, we calculate the match probability match_prob by subtracting prob from 1. When we run this code, the result is 50.7%. Let's summarize the key takeaways from the birthday paradox. First, it is counterintuitive. Small groups can create surprising collision chances. Second, there is exponential growth in the number of pairs. Pairs grow much faster than people, increasing the likelihood of shared birthdays. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.